Good evening. Today we'll discuss the next part of the projectile motion. One of my video I have derived the horizontal range, time period, and the maximum height a projectile will attain, and all the derivations I have done in one of my video. So in this video, what I'll discuss is I'll solve one or two questions and some more concepts on projectile motion. So as I have discussed in the previous video of my projectile motion, that when an object will fly from certain and with certain angle to the horizontal, after some time it will reach the ground again. So it will attain the maximum height and it will reach the ground with some final velocity. Now, when the object will be projected with certain angle, that is with the horizontal, okay, but it will move under the action of gravity only, okay. So if you remember, then and suppose a projectile is projected with certain angle theta from the ground, then it will reach a maximum height and it will strike the ground with certain velocity, okay. So today what we will do, now if the projectile is not projected from the ground with certain angle theta, it is projected from a height, let's say from the top of the building or a tower or a hill, okay. So from certain height, if the projectile is projected with certain initial velocity, okay, suppose someone standing on the tower, will kick the ball, okay, will push it or will kick the ball with some certain initial velocity, then the ball will again fall down to the earth under the action of gravity, right? So in this case, when the projectile will be projected from certain height, then certain things will calculate. The things which you will calculate here is with what velocity it will strike the ground. Okay, let's say this is y, this is your velocity v. What velocity it will strike the ground? Let's say this velocity, this angle beta. Okay. Also, we'll calculate what will be the velocity v here if the ball is projected with certain initial velocity, okay. Also we can calculate how far the object will fall down, what will be this distance, okay. So it is just extended case of the previous one, the main case. So in this case, what we will discuss is, you can see here we'll basically discuss that the object is thrown from certain or projected from certain height. Then here only ux component will be there, okay, no uy component. The object will not move upward direction from here. This is the maximum height, right? This is very important. So in this prediction, what we will do, we'll write down some formulas, then we'll solve one problem. So the important thing here you can note, observe that here the ball is thrown horizontally. That means the initial velocity will have only x component. Every vector has two components, right? Suppose this is a vector, it will have some, suppose this is a vector u. We have also done this case in our last projectile video. So it will have, suppose theta angle, you will have one component on x-axis, that is u cos theta, which we can say ux, that is the x component of this vector u. Now you will have another component along y direction, it is called u sin theta, and you can say it's uy. Okay. Now how you will get this u again? This u vector is now resolved into two components, in two parts. Along x-axis something, along y-axis something. Now this vector u is resolved into two parts. Now how will you get u again? Just you have to add these two parts, right? So how will you do that? Simple, right? So this uy is here, you can say this is also uy. So now you can see simply this magnitude of u will be ux square, Pythagoras theorem if we use, ux square plus uy square under root, isn't it? Why I am doing this? Because here we need that. We'll use this concept of the resolution of vector or the rectangular component of vector here. Clear? So let's understand this thing. So here only ux component is there, vector x component is there, because the force is applied on or kicked or pushed with x direction only. From here the object will not go upward direction, no further, it will not going upward, so there is no uy component, there is no force acting on the y direction, so I can write uy is 0 here. Okay, very important point. uy is 0 here. Now three things we'll calculate. Remember, one will calculate v, will calculate beta, with what angle it will strike the ground, or it will make with the horizontal, this is beta, and also we can calculate this distance, how far it will strike in the ground or in the horizontal direction, that is we calculate x. Also we'll calculate this y equation, and also we'll calculate the time. So these 4-5 things we will calculate from the concept. So how will you do that? First let's discuss the b, because we are here. So how will you calculate b? So again, let's say this is so the ball is kicked, it is on a with a projectile motion, it is striking the ground. When it is striking the ground, it's making an angle with some angle, and that angle, let's say, is beta. Okay, here also opposite angle, it's also beta. So this angle is beta. Now you see, if it is beta, this is b, you can write down, break this vector into its component form. So b beta, this direction, b x, that is b cos beta, and in y direction this is b y, that is b sin beta. Is it clear? Now how will you get v? How will you get v? Now v will be just like here this formula. So v magnitude will be vx square plus vy square under root. Clear? Achha, how will you get beta? Very easy. This is by means this is by. So tan beta you can write p by b. perpendicular by base. This is beta. So you can write tan beta. Tan beta is equal to Vy by Vx. If someone will ask you beta, what is the angle? Inverse, tan inverse, inverse trigonometry function. So tan inverse Vy by Vx. Then beta done. V done, beta done. How will you find y then? Let's go to the y. Okay. So how will you calculate y? Now y. Achha, y equation. S is equal to ut plus half at square, you know, equations of motion. So what is u? Y. Y is the height along this y axis. Okay. Displacement along y axis. So I can write ut plus half at square, equation of motion. Clear? But here, as I am writing y displacement, so everything will be in y case. Uy, this is also ay. We have done in while we are deriving the projectile case, we have done such we have noted in such a way. Okay, so notation is not new. So this subscript y means the initial velocity along y direction. Okay, the subscript y means here ay means it's nothing, no new acceleration, it's just the acceleration along y direction. Okay, so what is uy? Uy is 0 here, no motion along, no velocity along y direction, only it was pushed with initial velocity ux. Okay, so this one is 0, so we can write 0 plus half ay t square. What is ay? Now half ay is your gt square. So y is equal to half gt square. You can remember this, or if you know the concept, you can, because in JEE or NEET exam, sometimes the question asks find the time it will take to reach the ground. A ball is pushed from or kicked from a cliff or a high tower or from tall building. The ball is kicked, and it is how much time it will take to reach the ground. Okay, so you can use this equation directly, half gt square, and the building height is given. Suppose the building height is given, directly you can calculate the time. Clear? So y done. T also you can find out from here easily, right? So both way you can find out t, from y and from x also you can find t. So if information is given like the height of the tower or building, then you can use this equation. So t will be equal to 2y by z under root. Okay, so this is your time if height is given. Achha, x. Now let's proceed for x. So what will be x? As I told you, displacement along x direction or horizontal direction, where the ball will reach the ground, or how far the ball strike at a point on the ground. What is the distance from tower or building to that point where the ball has struck? Okay, so this type of question, the distance in the horizontal case. So you will calculate. So for that you need x. So x is equal to ux t square plus half a t square. But again I write x everything. Where subscript x? Why subscript x? Motion is along x axis. We are writing the displacement x here, right? So what I will do? Ux is the initial speed with which it was pushed or kicked, initial velocity. So it is ut. So it is as it, we will keep it as it is, that is ux t. And what is ax? Ax is 0, no acceleration, it is pushed with some initial velocity. Very important, remember, pushed with some initial velocity, no force after this, no any means there is no other force in x direction after the initial push. एक बार push कर दिए, ठीक है? Once you pushed it, once you applied force on the object, then you are not applying any force on its path. रास्ते में कोई भी force हम लोग नहीं दे रहे हैं. Okay, so what? So it will fall down under the action of the gravity only. Okay, due to the attraction of means of the earth mass. Okay, because two masses they attract each other according to the law of gravitation. So the earth is pulling, will pull this object, lighter object towards itself with the force of gravity. So that will be acting on its way. रास्ते में वही के काम करेगा, वही force. There is no other force on x direction. So gravity is pulling constantly downwards. Downwards means y direction. So no other force in x direction. So only initial force, initial velocity ux, which will be here also x component will be vx will be ux only. Vx only. Vx is equal to ux only, but vy will not be same. Okay, vy will not be same. We'll also calculate vy, and vx is ux. Very important. Final velocity along x direction is your initial velocity. ये भी पूछ देता है कभी-कभी. ठीक है? Along x direction, along horizontal direction, the velocity is same, but y we will calculate. Okay? So uxt. Okay, so uxt and plus 0. Why? Ax is 0. Ax is 0. Clear? Because there is no force on x direction, no acceleration, no force acting on x direction. Now, so x is equal to uxt we got. Okay. Sometimes x is asked, so how will you do? Your initial speed will be given, time will be given, you can multiply and you can calculate. Clear? Now, as I told you, Vx is here. What is the Vx? Vx will be equal to initial speed. Many times in the problem we require this. Okay, Vx you can find out. Now what is Vy? Okay, last one we will calculate. What is Vy? What is Vy? V, equation of motion again we will use. V is equal to u plus at. V is equal to u plus at. Now again I told you, if it is y component of V, so here only uy will come, and here ay will write, because the y component of initial velocity, the y component of acceleration also will work here. Again uy is 0 from the initial condition, no velocity along y direction initially, so uy is 0 initial, so final velocity along y direction, that is Vy, will be ay into t. So you can calculate ay is g, so or you can write Vy is equal to gt only. Okay, final velocity along y direction is gt only. Okay, so this is your concept behind the projectile when it is thrown from a certain height. एक हाइट से उसको पुश करेंगे और फोर्स अप्लाई करेंगे हॉरिजॉन्टल डायरेक्शन में ux direction with initial velocity along x direction, then these things will come up. But there is nothing new. These things just are some special cases. We are using the same equation of motion, but in some different ways. Just you should know the concept behind it. Now let's go for the problem. Quickly, let's discuss a problem. Then we will complete this type of problem. So here, whatever the formula I have written, all the formulas are important for your JEE and NEET examination. Many times the question comes based on this cases. So I'll summarize it for 1 minute, then we'll discuss the problem. So the question y is we got, that is half gt square, x we got x ux t, beta we got vy by vx, we got tan inverse vy by vx, ठीक है. vy we got gt, बस this one t you can calculate from any given data, ठीक है. So these are the things you should know. Now problem is, write down, a projectile is fired horizontally with a velocity 98 meters per second. I'm just drawing the diagram and summarizing it, not writing the question in detail. So with a velocity 98 meters per second from a top of a hill of 490 meters high, ठीक है. So the hill is of 490 meters high. That means y is given. Now a projectile is fired horizontally with a velocity 98 meters per second. Some projectile, any object is there, it is fired horizontally with a speed ux is given 98 meters per second. Now find the time taken to reach the ground. So it will come and reach the ground. So the question is find out time. Then the distance of the target from the hill. A hill से target. This is a target. Suppose okay, you want to fire the bullets to some other or destroy some terrorist camp or other camps. Okay, so camps. So how far is it from this hill? Okay, so this distance is, the distance is also asked, that is x is asked. Then the velocity with which the projectile hits the ground. So it hits the ground with certain velocity, let's say v. So that is also asked, the velocity. Okay, v is also asked, and also asked with what angle it makes with the horizontal. Beta is also asked. What is the angle with the horizontal? That means beta is asked, angle is asked. Okay, very easy question. Once you know the concept, it's very easy. So first we'll calculate what is the time. How will you calculate time? Formula is with you. Height is given, so best use this one. Okay, z is known to you. Use z as 9.8. Height is 490 meters. So 1 by 1, let's calculate. So y is equal to half gt square. Y is kitna y? 490 meters is equal to half g is 9.8 t square. So t square is equal to 2 into 490 by 9.8. So this is 980 by 9.8. So kitna multiply? How many? 9.8 into 10, 98, 100. Okay. So 100. Then t square is 100. This is, so time is square root of 100, 10 seconds. Clear? Time आ गया. Now you got the time. Time is 10 seconds. Next, how far it will strike the your, or it will hit the ground from the hill. Okay, so that means x is asked. Initial speed given, x formula is uxt, very easy. Time mil gaya, time we have now time. So x is how far it will strike the ground. X is equal to uxt, initial horizontal speed, ux, remember uxt. So ux is 98 into t is 10, 980 meter distance. So this distance is 980 meter. It will hit the ground at 980 meter. Clear? Now the velocity. What will be the velocity? So to calculate velocity, first you have to calculate vy and vx. देखो इधर एक important, here it is important ना. vx कैसे मिलेगा? मैं बोला था vx is ux, because this ux initially जितना force डाला गया था initially ux के direction में, there is no force in x direction, only gravity uy is changing constantly and it is becoming the finally vy, but ux is not changing, it is becoming vx in the final also. So final also vx is equal to ux. ठीक है? So vx is equal to ux is equal to 98 meter per second. Now vy, how will you calculate vy? Formula vy is t na. So g is 9.8, t is 10, 98 मीटर पर सेकेंड. vy vx हो गया. ठीक है, अभी क्या करना होगा? वेलोसिटी v. तो v कैसे मिलेगा? इजी, magnitude of velocity v is equal to, just you have to add it. Clear? So v x square plus v y square using the Pythagoras theorem. You know the coefficient squares, root over will give you the magnitude of velocity. So it is vx is 98 plus 98 square under root. So कितना होगा? 98 square, 98 is 98 square. So this is 2 into 98 square, or if you know, you can write this is 98 root 2 meter per second. So now you got v. Now last one, what is angle? What is the angle? You can easily calculate. No, angle is vy by vx tan inverse, or 10 beta is equal to vy by vx. ठीक है? So vy is 98, vx also 98. ठीक है? That means 10 beta is 1 when tan theta is 1. Tan theta is 1 when? Tan theta is 1 for 1045. So you can write 1045, or you can write beta is equal to 10 inverse 1, which is equal to 45 degree. So it will strike the ground with 45 degree angle. Clear? It will strike the ground with 45 degree angle. The magnitude of velocity is 98.98 root 2 meter per second. How far it will strike the ground? It will strike the ground at a distance 980 meters from the hill. The time it will take to reach the ground, okay, is 10 seconds. After 10 seconds, it will hit the ground when it is thrown from a height or from the hill of height 490 meters. Then it will strike the ground at a distance 480 meters. Clear? So in that way, I think of all the aspects I have covered, these are the questions come sometimes angle, sometimes distance, sometimes velocity, sometimes x component of velocity, y component of velocity, everything comes repeatedly maximum time in NEET and JEE exam, you will find this type of question comes. Okay. Anyway, so let's stop today. It's getting lengthy. In the next video, I'll make some new concept. I'll discuss some new concept and solve the problems accordingly. Okay. Thank you all. Let's stop here. Okay.